In this chapter, we will learn how to visualize the data using our space package. We can categorize the visualization into two groups. One with bivariate analysis is using plot and another is with univariate analysis by using histogram and boxplot. Bivariate analysis is a simultaneous analysis of two variables as it explores the concepts of relationship between two variables for association or differences across the group. And univariate analysis separately studies the variable in a data set. The key factor of univariate analysis is that only one variable is involved. Therefore, it provides inferential or descriptive summary for each individual variable of its own. So let's start with bivariate analysis using plot function. First, load a sample data. For this example, load the inbuilt dataset iris. This is a famous iris data gives the measurements in centimeters of the variables sepal length, width, and petal width, respectively, for 50 flowers from each of three species of iris. Then define the x variable and the y variable. For example, x is equal to sepal length and y is equal to petal length. In the plot function to explore the concept of relationship between two variables for association or any differences across the sepal length and the petal length. To add x and y labels, use the word xlab for x variable and ylab for y variable, and main is for the headline of the diagram. Now let's make the diagram a bit more attractive by adding some colors and symbols to it. To add a new color, use the word col is equal to green, and for plotting symbols, pch is equal to 3. This gives the same plotting symbol for all the data points. However, we want to differentiate the plot values with the types of species, then specify our plotting symbols pch is equal to s.numeric iris $species, and also the same for the color using col is equal to iris $species. Now, alternative to pch is the cex, where cex changes the size of the points corresponding to different species. However, for both pch and cex works in numeric data type. Therefore, we have to convert it with s.numeric. To add a legend over the existing plot, type legend x is equal to top left and y, where x and y are the positions of the legend in the plot. Next is our univariate analysis. Boxplot is a standardized way of displaying the distribution of data based on minimum, first quantile, maiden, third quantile, and maximum. It helps to identify the skewness and outliers. Outliers are the extreme values that doesn't match with the patterns of the data distribution, possibly due to human error. Skewness is the asymmetry in the statistical distribution, when the mean is greater than most of the data is distributed to the right side. It's known as right skewed or negatively skewed. And when the mean is smaller than maiden, then most of the data is distributed to the left side, which is known as left skewed, or we can also say positively skewed. Now, since we are clear with the concepts, we can easily find the values of mean and maiden using this summary. Now, let's understand what is boxplot with the help of an example. From the boxplot diagram and summary results, we can infer that mean is slightly greater than maiden, referring that the data is slightly distributed to the right side, hence positively skewed. And we can always use a question mark to know more about the parameters of boxplot. To create multiple boxplots at the same time, just define the variables inside the function. And do remember, the boxplot graph only works with the character or factor variables. Our next example of univariate analysis is the histogram using a hist function. The generic function hist computes the frequency distribution of a variable via histogram of the given data values. To use the hist function, all we need is to define the number of bins, that is the breaks, xlim, which is the range of x-axis, and labels a logical indicator true or false if we want to label the frequency of each bin. Here, in this example, we have defined the number of frequency distribution buckets in breaks is equal to 10, then the range of x-axis, which is from 0 to 5. If we want to show the density instead of frequencies, we can define the frequency is equal to false and use lines function additionally to plot the density of the variable on the top of the existing plot. Multiple plots using par. Par is used to set or query graphical parameters. To set number of plots at a time, define the MF row in the format row and column inside the par function. Here we have one row with two columns. Plot number 2 graph will observe both the graphs are in the same plot. Use def.off defoff to turn off the multiple plots feature. Next, we will learn how to create elegant data visualizations using ggplot2, the grammar of graphics.